When you talk about the small particle area, uh, the math that's involved in the small particle area, um, when I think about small particles, you think about the atomic scale. You're talking about the subatomic scale.
Well, that's what physicists are interested in
Yeah.
mainly now,
Mhm.
which is describing what's going on inside the nucleus of an atom.
Mhm.
And the more massive the nucleus is, there's a lot of interactions that are occurring there. I mean, the nucleus is heavily positively charged and divisible. In other
Mhm.
words, there's protons inside of there,
Mhm.
and they're all packed together in a tiny amount of space. Electrostatically, in other words, the positives repel one another, right?
Yeah.
So it's a very unstable situation by intuition,
Mhm.
but because of the rules at that scale, the ones that are non-intuitive to us, uh, that happens.
Oh, so there's actually something different going on than what we would intuitively say should be happening if we were dealing on a larger scale.
Absolutely.
And one of those examples is the fact that you've got a very positive core to an atom that you would think that it would just kind of explode. I mean, and just push
Absolutely.
everything away, and it doesn't. Right?
Absolutely.
And so, uh,
The glue inside there.
so when you talk about the glue,
Yeah.
I mean, what's
Well, those are forces,
yeah.
and those are the forces we really don't think about in our daily existence.
Mm-hmm.
But of course, they make atoms happen,
Yeah.
right? So there's a strong nuclear force, there's a weak nuclear force, there's forces, and when I say forces, I mean things like positives repel. I think that's
Mhm.
electrostatic forces, or gravity. You drop something, it falls to the ground. That's a force, right?
Yeah.
Well, there's forces that occur on that scale
Mm-hmm.
with those particles that keep that together, that are strong enough
Mm-hmm.
to outweigh the electrostatic forces to hold this nucleus together.
Underlying that is the mathematics.
Mathematics are the language that it is required to
So if
describe
you're
the world.
discovering something new, you may in fact, if you observe something new, you may in fact have to create mathematics
Absolutely.
to
Yeah.
match that physical observation with a set of mathematics. When you see all these equations with all these strange symbols in it, that's what somebody did, is basically came up with a symbol that represents some aspect of what they observed. It wasn't defined before in mathematical terms.
Right. I mean, notation is incredibly useful. So,
Mhm.
for example, if we write 3 times 3, what we're really saying is add the number 3 together 3 times.
Mhm.
That's a notation,
Yes.
right? And so is 50 times 50. It's taking the number 50 and adding it together 50 times.
Mhm.
Okay, now we could write that. If we just had pluses to work with, that would take us an incredibly long time to write that
Sure.
down.
Yeah.
Okay, but along came multiplication, and we have a notation that summarizes that process of adding 50 times together as 50 times 50. Physics does that over and over again with math.
Oh,
Okay?
I see.
So you have some phenomenon that just isn't conveniently described in one picture, in
Mhm.
one page, let's say,
Mhm.
and they develop a notation for it, whether it's an integral or a summation statement or a matrix of some sort. It's compact
Mhm.
and easy to move around, and our minds really do well with that.
Okay. How often do you have to publish in order to stay on top of things?
Different fields will publish in different rates. So the people who work on CERN,
Yeah.
they'll have maybe 2-3 publications per year.
Mm-hmm.
That facility.
Yeah.
I mean, that's the big ones,
Yes.
and there'll be 100 names on it.
Mm-hmm.
100 people who contributed to that experiment. And then you go up to the field I work in, biophysics. That's 10 people or 2 to 10 people.
I see.
And it also depends on your preference. Sometimes it's worth waiting to get the big piece
Mm-hmm.
knocked out and described in a complete format. Those big papers go into Nature and Science and things. and to hold off until you have that complete story, and that's some people's preference, or
Yes.
the other preference is to publish piecemeal. So you get a little discovery, you publish that in a lower ranking journal of some sort, and you just keep your body of work going. It's about seeing what's there. Let's say we've got the rovers on Mars, right? Are we going to take advantage of what they discover? Perhaps someday in the future, but really what we're doing now is foundational science. We're just trying to understand what's out there, what it's doing, what's going on, and the same is true for particle physics.
Yeah.
The chances that it will be applied someday look small at this point.
Yeah.
There doesn't look like there's any real reason to do that kind of thing, but it's about understanding our world. I mean, the same as, the nearest star to us is more than 4.5 light years away. So even if we're traveling at the speed of light, it would take us 4.5 years to get there.
Yeah.
To apply that is challenging, but we as humans really want to understand our world. And there is, and from those who do that kind of science, their goal shouldn't be to really try to find a way of applying this. Their primary focus is to just understand what it is. What are the rules at that scale, or what are the rules there? So to try to understand how we're going to apply these things we learned from CERN, for example, is not a useful way to think about it. Okay. What we're doing is really a human activity to just try to understand the world we live in.
Hey, that's excellent. So Greg, thanks an awful lot for taking your vacation time again to share with us an element of science which many people are probably not familiar with. And so I'm extremely grateful to have this opportunity, and I hope our audience enjoyed this program. Again, our objective is to inform, educate, and promote. And in this particular case, is getting education, a level of education, pursuing science, and considering physics. So thank you very much for joining us, and aloha.